Subscribe now and click on the bell icon to never miss learning from Vedantu.
Unsaturated solution. A solution in which more quantity of solute can be dissolved in a given temperature is termed as unsaturated. Let this be the example which we were discussing of halwai, right? 3 kg can be dissolved, but right now we had only 2 kg of sugar added. Then the solution will be known as which solution? Unsaturated solution, right? A saturated solution represents a state of equilibrium between solute present in the solution and solute precipitated from the solution, right? If such a solution is heated, it becomes unsaturated in the sense that it can dissolve more of the same solute. Let's go for halwai, right? Let the temperature was 30 degrees Celsius. You could dissolve only how much of sugar? 5 kg. Now the sweet maker start increasing the temperature, and temperature go to say 100 degrees Celsius, say 200 degrees Celsius. He can take it to 200 degrees Celsius. We will be learning in this chapter the elevation in boiling point. Then more of sugar can be dissolved. Say he is able to dissolve 8 kg of sugar into that. This solution will be termed as supersaturated solution. See what he want to say. Supersaturated solution. Super, it can dissolve more. Right now you are unsaturated, right? I'm adding knowledge into you. So at a stage you will become saturated. But then I will say, nahi bachcho, we have to do a little bit more. Then I will try to make it little bit, not more, super saturated, little bit of more knowledge than what is required. That is going to be my level beta. In a super saturated solution, no more solute can be dissolved even on increasing temperature. When such solutions are cooled, they will crystallize the solute and become saturated. It is going to be known as metastable state. Metastable state. Devesha, give me time beta. It is known as elevation in boiling point, right? It will take beta around 2 hours to come to that point. I can increase the temperature, right beta? Now imagine that halwai, that sweet maker has left his sugar solution there and let it cool down. The same thing which I was given example. After some time, you will find that sugar start crystallizing on the sides or maybe on the wherever it is possible. That is what you are going to get is a metastable state, right? Often, this is very interesting. Focus. I'm going to tell you the concept of artificial rains now. Often, supersaturated solution will crystallize if they are shaken or if dust gets into them. The dust can give a site for the ions or molecule in the solution to gather around. This is the process known as nucleation. Sometimes solution can be induced to crystallize by scratching with glass rod inside the flask. This may produce nucleation site on the glass or may agitate the solution and induce crystallization. Clouds are seeded with tiny crystal of silver iodide. The crystal acts as a nucleation site for water nucleus which gather and make raindrops. This is known as artificial rain. You know, we had Olympics in Beijing around 10 years ago. Beijing in China is a very polluted city, much more than our Delhi or maybe any Indian city, much more than that. Now, what they wanted, the Chinese wanted, they wanted the clear sky. Why? The whole of the world has concentrated in Beijing. I think it was 2008. Anyway, no dispute, beta. It was in 2008, most probabilities. They wanted clear sky. So what they used to do was, in every day in the morning, they took planes. They took planes to the sky and they sprayed crystals of AgI. What AgI did was, there was already water vapors, but there was sand, or you can say dust was also there in it. When it coagulated, the rain, artificial rain, brought all the dust particles down, and the sky used to become clear. They used to induce artificial rain every day. I learned this is happening in Maharashtra or maybe Karnataka at some places also. There are clouds, but they are not giving enough water to crystallize. Then what do they do is, with some plane, they are adding crystals of silver iodide. Silver iodide provides what? Nucleation site. Around silver iodide, water starts coming. It is certainly coagulation, beta. It is certainly coagulation. Coagulation is sitting down, right? And that is the artificial rain. I tell you one interesting one more phenomena, beta. You will enjoy solutions, right? You will enjoy solution. It is around you. It is happening around you. Most of you young scientists, I will call you as young scientists. Beta, please don't judge me by my drawing. My drawing is not good, right? No reason, beta. It's non-reactive. That's it. No special reason, beta. Okay, let it be some cold drink bottle. Please do not do in front of your mother, right? You understand why not mother, hai na? Take a cold drink and now add simply sugar or NaCl, right, into that. What will happen? You will add NaCl solid. What will happen? In cold drink we have gas. The gas will start rushing toward sodium chloride or sodium particle, and you will see the gas coming out of this. That is also known as nucleation. Have you done this experiment? You can do it today, but don't do take little bit of cold drink. Say this is your glass, just add little bit of cold drink. Otherwise it is going to come out, right? Add little bit of salt, shake it, you will see the bubbles are coming out of that. What is the process known as nucleation, right? And then you can drink it. It will do no harm. You must have seen that experiment, mint with a hole, hai na? ENO is something else, beta. ENO has sodium bicarbonate. When you add water into that, my son, that is going to produce NaOH. Don't worry, it is not going to make any harm to it. It is going to produce water and carbon dioxide. This will be producing effervescence. Right? ENO is something else. Do you know? I have added a question on sodium bicarbonate also, which I told you is going to be a very challenging question of this chapter. So just a minute. Yeah, we're going to do a good question. You will enjoy it. So my dear son, do not worry about a lot about solute and solvent. There are much larger things, much important things waiting for you to happen, right? Worrying about what is solute, what is solvent will not take you to the JEE advanced or maybe the NEET advanced level. So we need to work out every type of problem. Come with me. I promise that nobody can beat us. So you can see my confidence. I'm telling you that you are going to be best in India. And I'm giving you this statement because I have the substance, right? In terms of you, I'm not confident because of myself. I'm confident because of you. You are the best, right? You have a desire to succeed, but I have to give you the shape. Some of you might be understanding little bit of Hindi. आप एक कच्ची मिट्टी है, तो हमें उसको एक अच्छे बर्तन के जैसा शेप देना है. If I'm able to do that, we are going to rock. And if आप ही बार बार गिर जाएंगे बेटा, you are not allowing me to shape you up, then I won't be able to do my job in a proper way, right? You will prove, but at the same time, I said you in the first go, I am the driver. I'm going to take you to the right direction. See, I'm giving you a very crude example, but it is the right example. We have beta this type of passage. Let it be a road. Here we have target, T for target, right? We will do it, but it is only if you are working in honesty, bilkul total 100% honesty and smart fashion. So if I am the driver, I'm going to take all my students in this direction, logic, target, approach. But if you people do not know, so what you people are doing, you are sending a gypsy waves, vibrations. We are here also, right? So proceed in a direction. It is not only hard work, it is going to be better smart work, which is going to make us smart. It is not only learning, it is solving a problem, which is going to make us win, right? So please, anyway, gappe to chalti rahegi. Let us proceed further. Nucleation, bache. All of you can do one thing. By next class, you should learn taking screenshots, right? You should learn taking screenshots. But hour and apart, this lecture will be available for you. This will be available for you, although it takes little bit of time, beta. Sure? Okay. Strength of solution. A topic to watch. Strength of solution. It is defined as quantity of solute. Nobody will memorize anything. I hope you understand. CTM, whenever I write this, only then you are going to memorize. Otherwise, just read it like a novel. It is defined as, what is defined as? The strength of a solution, given quantity or volume of solution or solvent. While expressing concentration, temperature is supposed to be constant. We will learn if you change temperature, then the concentration is going to change, right? So we will try to keep the temperature constant. It's supposed to be constant. Whatever terms I'm going to discuss with you will be at constant temperature. The first is, it is grams per liter. Sorry, wait. Gram per liter. It is a weight of solute present in 1 liter. You know, 1 liter is equal to beta 1000 centimeter cube, or it is equal to 1 decimeter cube, or it is -3 meter cube. Right, bache? This is the term you should remember. 1 liter is equal to 1000 centimeter cube, 1 decimeter cube, or 10 to the power minus meter cube. This is, I wrote CTM. See, this is important. So what is strength in gram per liter? Amount in gram per liter. Gram per liter. It can be taken as gram per decimeter cube. Do not memorize it. I will put problems on it. That will make you understand. Mass by mass of solution. Right? It is also called as percentage. Simply, it is written as percentage W. W by weight. Mass of that component, total mass into 100. In medicine and pharmacy, right, is mass by volume percentage. It is a mass of solute dissolved in 100 ml of solution. 100 ml of solution. See, bacho, now I wrote CTM. I wrote CTM, commit to memory. I introduce a term known as isotonic. Tonic is a chemistry word, chemical word. Iso means same, tonic means same strength, right? Same strength solution, right? Then it is copy to mind. Or why? I said commit to memory. You said copy to mind. That's okay. Copy to mind. Good. Thank you. And if a solution is hypotonic, that means it is having less strength than another solution. Wait for that. I do not know osmotic potential. Let the time come with it. Hypertonic. Hypertonic. Hypertonic means solution having more strength than other solution. More strength than other solution. Correct? See, beta, there are two solutions which everybody should remember. Everybody should remember. It is 5 dextrose. What does it mean? 5 gram of glucose in 100 ml of solution. 100 ml of solution, that is obviously going to be water, right? Another solution is beta 0.91%. I can write 0.91% to be accurate. Now, please know 0.91% बच्चों, it is saline. Saline is NaCl. That means 0.91 gram. 0.9 gram. Oh, I wrote percentage. I should be writing gram of NaCl in 100 ml of solution. Why I am stressing upon these two solutions? Solution 1, solution 2 are isotonic with human blood. Correct? Whenever a patient is going to be transfused any solution from outside, so either of these two solutions should be used. We will discuss it later on. If you infuse a concentrated solution, hypertonic, that will create some problem. If you infuse a less dilute solution, say you add water into a patient's body, he or she is going to die. If you add a very much concentrated solution other than this, then the death is certain. Okay, so these are two solutions. What are these? Which are isotonic with human blood. This is not important, beta. This is very important. This is important from your chemistry point of view, right? Everything is important. So please, you will copy everything which I am speaking. Everything I am speaking. So that is the reason, beta. I told you in the beginning. On the top, which will set my notes and assignment. On the top of any course, everywhere you are going to do will be my notes will be coming, right? So अभी तो शुरू ही नहीं हुआ बेटा topic. Okay, so that is going to be the isotonic. So you understand? So what is weight? What is percentage by weight? What is percentage by volume? And what is weight by volume? Weight by volume. We have three types of solutions which we are going to discuss. Let us move further. Let us see. Are you able to understand on this? हाँ Smriti, keep on asking beta. See beta, I have deliberately taken the number also from your NCERT. So this is, the number is also from the same, that is 2.1. You will find it in a book. What is the mass percentage? Tonic water is beta, they have made some commercial thing. Tonic water is meetha in taste. It has nothing to do with chemistry. Strength can be expressed in weight by volume. Strength can be expressed in tens of ways which we are discussing. चलो इस क्वेश्चन को करते हैं स्मृति. What is the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride? Very simple. Say weight percentage of Hanji Veda. I told you to keep calculator during the class, right? During this class, it will be what beta? How much is going to be the benzene? 22 gram divided by 22 plus 122 into 100. You got it? What is this? Weight of the component. What is this? Total weight. I'm believing whatever answering you are giving. Are you calculating, Vinay, on the calculator? Vinay, hello. Are you using calculator, dear? So if you are using calculator, then I believe you. Okay, beta. Now, Vinay, what is the weight percentage? Please calculate for me. 15.27. Okay, approximate. Very soon, after few lectures, I'm going to tell you the techniques for your competitive exam, how you are going to solve this question there. It is around 15%. Around, okay. What is percentage weight of CCl4? It is simple. 122. 22 plus 122 into 100. I'm believing you. It is 85.72. That's good enough. Is this type of question clear? Can you calculate the percentage by weight? Percentage by weight. It is weight of the component divided by total number of weight. That is, I have taught you. Very easy, beta. This is comparatively, abhi to और topic आएंगे, that will become even easy. Don't worry, beta. Everything cannot be taught in one. Okay, I want to show you the slide. Okay, you enjoy this, beta. For my class, please use calculator. So this is a wonderful percentage we are getting, है ना? This is the first numerical we have solved. Okay जी, चलिए आगे चलते हैं मेरे प्यारे से बच्चों. This is the question. Tighten your belts. First numerical of class 12th. Tighten your belts. A solution is obtained by mixing 300 gram of 25% solution and 400 gram of 40% solution by mass. Calculate the mass percentage of the resulting solution. Sorry for interruption, bacho. After the class, you're not going to read only this. You're going to read the all topic again, right? Then your understanding level will increase, right? Then your understanding level will increase. So let us do it. What do you mean by this? Perfect. There is one solution which is 25%. Right? There is another solution, Vinay, perfect, Vinay, which is having how much percent? 40%. Vinay, what does this mean? That is 25 gram of B. You understand what is B, beta? Solute. In 100 gram of total solution. Is it clear? What does this mean? 40 gram of B in 100 gram of solution. 100 gram of solution. Correct, bache? So now I have given how much? I have given 300 gram of this. I have given you 400 gram of this. Perfect. So 100 gram contains how much? 25 gram. 300 gram of this will be containing how much? 75 gram. Same here, 100 gram will contain how much? Shantanu 40 gram, and beta 400 gram will contain how much? 160 gram of solute. Then what is percentage by weight? What is the solute? It is 40 plus 70, 160 plus 75. It is 235. Please check it. 235. You will be checking my calculation also. And beta, what is the total solution? 300 gram this and 400 gram of this. So what is the total solution? 700 into 100. What is the answer, bacho? Around 33%. Around 33%, right? I'm not using calculations, so I'll be using approximations. So you can calculate percentage of solvent. Either you go by this, subtracting this, or you simply do 100 minus 33. That is approximately how much? 67%. 67%. So we have launched officially the chapter known as solution. What is solution? It is a chapter containing lots of numericals, beta. Lots of numerical. How much numerical in this chapter? Don't panic. It could be around, don't worry. It could be around 80% syllabus of this chapter is the numerical part. And one thing more, beta. An interesting question cropped up. One of my friends said, sir, this was 84.72. Beta, this is not your final board exam. So here it does not matter. But Once I'm checking your theory exam, then I will partially deduct your marks for that. हाँ बेटे, this is JEE level. This is JEE level. You know what are going to be the rewards of understanding all this? You can't imagine. So do you think without working smart, we are going to get it? Not possible. That's the hard work has started. That is the smart work has started. Everybody know his or her homework, right? Try to understand what I'm doing. Don't worry, bete. So for organic chemistry, undoubtedly, I tell you, you are not good in the general organic chemistry. Chalo ji, this question, I will do that. You check it. You simply check it. It was 6.5 gram of aspirin. So percentage of aspirin will be 6.5. Now you committed a mistake, Vinay. Total is beta 6.5 plus 450 into 100. You got it? What is this beta? Weight of component. What is this? Weight total into 100. This is going to be percentage. हाँ जी, कैसे लिख सकते हैं? By W. Percentage by weight. Percentage by weight. It is 4.13. During your class, you should use calculator. During your class. So up to this part, we have done 3 questions. Are you able to understand? चलो जी, आगे चलते हैं. Parts per million. So, you know, beta, I'll be talking a lot with you. Chemistry is a language where we have to first make knowledge, and then we have to apply the logic. Like in your physics, you have to apply logic. There you have to apply logic. But in chemistry, we have to learn a lot of things, which is a syllabus. So, हाँ बेटा, this will be saved for you. Okay? चलो जी, parts per million. हाँ, it's not like this कि I'm teaching chemistry, but it is really a very good subject. But in spite of being a chemist, I say mathematics is the language of God. So if you're good in mathematics, then you can learn any type of science, any type of. You know, just a minute, beta, just a minute. In between, I'm stopping. You know, you want to be a scientist. So what is the frontier? Frontier matlab, what is going to happen after 10 or 15 years from now? So we are working, we are studying. Not that you are going to be a clerk in the bank, or maybe you are going to be data operator in some foreign bank. Every subject is good, beta. So this is the first lecture. So I'm telling you where you should be in the coming after say 10 or 15 years. I wish you to be a scientist. Grains. G for genetics. These are the topics of future, right? Topics of the future. R for robotics. AI. You know AI? AI stand for artificial intelligence. And N rightly said nanotechnology. And S for space science. These are going to be few topics of future where you should be thinking that you are going to be there after few years from now. Chalo, let's see how many of you are going to do that. So, artificial intelligence is a very good field, but dreamers cannot do anything. With the proper dreaming, you have to work smart. Chalo, parts per million. It is the weight of solute present in 10 to power 6 gram of solution, or we can say it is the number of parts by mass of solute per million part by mass of the solution. Right? How do you explain it? It is number of parts of the component by total number of parts of all component into solution. See, what do I want to say? It is ppm, parts per million. It is weight of a component divided by total weight, right, into 10 to the power 6. 10 to the power 6. Do you understand what you used to do in percent? You used to multiply it by 100. Here we are multiplying it by 10 to the power 6. And definitely it is used for dilute solution. It is used for dilute solution. And there is no condition that this is going to be used for weight. You can use it like this. It is volume of a component divided by total volume of the solution into 10 to the power 6. Into 10 to the power 6. 10 to the power 6. It could be volume also. And it is used for which solution? Dilute solution. Very dilute solution. Suppose I say that in a particular day, Delhi has volume, it is SO2 is say 500 picometer, 500 ppm, 500 ppm by volume. What does that mean? That there were 500 milliliter of SO2 in every 10 to the power 6 milliliter of air. You got it? What is this? 500. What is this? 10 to the power 6. Say, some scientists say we can tolerate, it is 50 ppm of arsenic. Array, don't worry about the quantity. Just understand. I'm quoting figures just to make you understand. 50 ppm of arsenic by weight in our blood. That means, say, now he's saying by weight, 50 milligram of arsenic in 10 raised to power 6 milligram of, say, blood is tolerable. Do you understand? ppm can be expressed in weight or ppm can be expressed in terms of volume. In terms of volume also. It is multiplied by 10 to the power 6. Give me a little bit of time. Every problem will be having numericals associated with it. Every problem will be having certain parts per million beta. Parts per million. Parts per million. Per million. Concentration in ppm can also be expressed as mass to mass, volume to volume, and mass to volume. Please do not memorize ppm, right? Let us wait for the problem to come. So in a way, ppm is mass fraction. What is mass fraction, beta? This is the mass fraction, you know. Weight of a component. Weight of a component divided by total weight. So this is mass fraction multiplied by 10 to the power 6. That is ppm. Like ppm, Dev, we can also have beta ppb. What is b? Parts per billion. What is the difference between parts per million and parts per billion? 10 to the power 6 and 10 to the power. Anand, try to solve it again, beta. If you're not able to understand, and we will have a discussion on the phone also. Okay, bacha? 10 to the power 9. This concentration term is used for very dilute solution where very small amount of solute is dissolved. For example, degree of hardness, concentration of chlorine in drinkable water. If A and B are two components, that's a repetition beta. Then ppm of A is mass of A, mass of solution into 10 to the power 6. The degree of hardness of water, it is just how much hard is water. By hard water we mean which does not produce lather with water, is expressed as ppm. For example, if the hardness of water due to presence of calcium bicarbonate is 30 ppm, lather, jhag, this means that 30 parts of calcium bicarbonates are present in 10 to the power 6 parts of solution of hard water. Parts per million. So what is parts per million? It is weight of a component divided by weight total into 10 to the power 6. What is ppm in terms of volume? Everything same. it will be difficult for me to make you understand this in Hindi, bete, because we will be studying this chemistry in English medium only. तो हिंदी में समझाना थोड़ा सा मुश्किल होगा. Volume percentage. That's volume percentage. This is for you to read. This is for you to read. Volume percentage. It is similar to that. Okay. See, I'm writing a statement. It is ethanol. Ethanol. Right? Aqueous. It is say 43.2% by volume. What does that mean? That 43.2 milliliter of ethanol in, hanji beta, 100 ml of G solution. Is it clear? What is volume percentage? Volume of our total volume of solution into 100. Similar to weight percentage, we have volume percentage. This is very important term coming. Molarity. Very important. I'll be using my method. So it is written for your notes also. But see. Molarity. All eyes on the board. Without this, we cannot move ahead with this chapter. Molarity. Capital M. Molarity, capital M. It is number of moles of solute. Give me time, Smriti. Give me time, beta. Number of moles of solute divided by volume of, this is volume, beta. This is number of solution in hanji liters. Remember, in a liter. So what will be the dimensions? Mole, no problem, video. Mole per liter. Mole per liter. It is also abbreviated as capital M. Abbreviated as capital M. Moles per liter. Right? See, you understand how do you calculate it? How do you calculate number of moles? Number of moles can be weight given divided by molar mass. What is this? Weight given by hanji molar mass. What is this? W by M. W by M. W by M. Number of moles. Correct? Say, I can write it like this, beta. Molarity. WB, this by MB into volume. Volume kiska? Volume of solution in liters. It is always going to be in liters. It is always going to be liter. Concentrate, beta. What is molarity? Molarity is number of moles of solute. Number of moles of solute divided by volume of solution in a liter. Divided by volume of solution in liter. Give me time. I hope I will be having few problems based upon that. नहीं, इस पे बाद में आएंगे. इस पे बाद में आएंगे. 2 मिनट देना. इस पे बाद पे आएंगे. Okay, बच्चे. Now see one more thing. See, I gave you, suppose beta, suppose the volume in milliliter. Suppose I give you 2 molar NaOH solution. What does that mean? 2 moles of NaOH in hanji 1 liter of solution. 1 liter of solution. What is molarity? Number of moles hanji divided by per liter of solution. Clear hai? Good. Chalo, let's close it. आगे चलते हैं. Number of moles per liter. Now see beta, this is going to be an interesting thing. This is going to be an interesting thing. एक मिनट, इस पे ही अभी ऐड करते हैं. उस पे भी अभी ऐड करते हैं. See बच्चों, we are given this much of solution. Say between you and me, this is, let it be 2 liter of 2 mole solution. 2 molar solution of NaOH, right? Certain volume. I gave you this much of solution. This much of solution is given out of this solution. Then how will you calculate mole of NaOH in this? Mole of NaOH in this. It will be given by molarity into volume. Mole of solution, mole of a solute can also be given by molarity into volume. Molarity into volume. Let us make a question. Let us make a question. Nahi beta, nahi. I have not given you volume. How many moles of NaOH are present in 500 milliliter of 2 molar NaOH solution? That's your question. 500 milliliter. Dev, concentrate beta. See how you are going to do. Moles is going to be molarity into volume. Moles is going to be molarity into volume. What is molarity? 2. What is volume beta? 0.5. Why? I have to take in liter. That is going to be how much? 1 mole. Is this relation clear? Moles can be given by W by M, or moles can be given by M into V for a solution. Yes, you know law of conservation of mass. What is law of conservation of mass? Mass cannot be created, mass cannot be destroyed. Agreed? Suppose beta, I'm going to tell you it is mixing of 2 solutions. Mixing of 2 solutions. Oi, Pondicherry, concentrate here. I'm from Pondicherry. So now, see here, we have one solution A of molarity M1. We mix, right? We mix another solution B of molarity M2. Right? Let this be V1, let this be V2. Then we mix it. How much is going to be the volume beta here? Total volume is going to be V1 plus V2. V1 plus V2. Agreed? Total volume is going to be this much. You understand? Number of moles here, Na, ha beta, number of moles here is equal to number of moles here. That's law of conservation of mass. How will you do that? M1 V1 plus M2 V2 is equal to M final V final. What is the relation? This is for mixing of 2 solutions. This is for mixing of 2 solutions. Correct? See, one more concept. It is dilution. That was mixing. That is bacho dilution. What is dilution? You have one solution, you add another solution into that, another solvent into that. Suppose you have stock solution. Nahi beta. Stock solution. What is stock solution? Concentrated solution. We are adding solvent into that. And that is going to be which solution? That is going to be dilute solution. Dilute solution. See, number of moles of substance will be here only, right? And this is definitely equal to this. This is definitely equal to be this. So how will you do that? M1 V1 is equal to M2 V2 for dilution. Stock solution matlab bete concentrated solution. We will be going very often to your kitchen. Suppose the summers are there. Your mom prepare a concentrated solution of lemon, right? Nimbu pani bana ke rakha hai. So when you come from your school, what you do is You take few spoon from that solution, you add it into a glass of water, you shake it, and then you are going to drink that. So what is a concentrated solution? Concentrated solution is known as stock solution, and it is going to be the solvent, a squash. Okay, it is going to be the squash. So bachcho, after the class I have tried to explain it. Shantanu, you will be hearing the words beta semi-molar. What is semi-molar? Molarity by 2. Decimolar, what is that? M by 2. Millimolar, M by 1000. Centimolar, M by 100. M by 100. You will read this. You will read this after the class. Right? You will read it. This is the topic where the last topic I'll be taking today. Then I'll be taking your problems and revision. Disadvantages of using molarity. The concentration depends upon temperature changes. Right? You understand what is molarity? Molarity, capital M. It is number of moles divided by volume. If you increase temperature, then volume is going to increase. Then volume is going to increase. If volume is going to increase, then molarity is going to be decreased. So molarity is going to be temperature dependent, right? Second is exact amount of solvent in a given volume of solution can't be determined unless the density of the solution is known. We cannot. I will tell you the problems, right? So after this, whatever is there, we will be taking in the next class, molarity. The next class, we will be having lots of problems to solve it. Problems to solve. These are the problems I will be taking it, and do not read it. Do not go beyond the topic. मतलब आपने उतना ही करना है till the time I have gone. I have given you problem. Those who wish to do can do it. But right now your homework is just revise it.
Subscribe now and click on the bell icon to never miss learning from Vedantu.